Okay, hi everyone. This is a video to teach you how to do vector drawing. So this is under the chapter on dynamics. Okay, so we're going to use this worksheet question to be the example. We have a lorry being pulled by two jeeps. Okay, there's a one pulling this way at 4,000 newtons, 30 degrees, and another one going this way at 15 degrees, right? So then you're asked to use a scale from 1 cm to 800 newtons, and you're supposed to draw a scale diagram to find the resultant force. So when it comes to this kind of question, first thing you do, you want to just write it down again. This is my scale. So sometimes the scale may not be given, then you have to come up with a scale. How do you decide on a scale if you really need to? You look at how big is your space here and see whether that your diagram can fit the space. And also you want to make sure that it is not too small such that you may lose some accuracy in it. So you want it as big as possible, but yet you'll be able to fit the page. Okay, so based on the diagram, I want to plan where my shape, where my vector diagram will be. So in this case, you will see that there's a force to the right, and even if I were to sketch it, this is how, if I were to do a parallelogram method, this will be roughly where the final diagram will probably look something like this. So based on this, I'll probably want to start off somewhere on the left side, which is so I have enough space to go to the right. So how I do it, usually I'll do a horizontal line and I'll do a dotted line. Only the forces lines I will use a solid line. Most of it I'll do a dotted line. Okay, I will put a marking here so to know where's my starting point. Now, in this case here, because my diagram is like this, I will want to mark out the 30 degrees first. So I want to draw the force on top at 30 degrees. Here, I'll mark out something like this here. Okay, then I'll extend the line. So it's okay to extend the line a bit beyond. Then after that, then you use a ruler to mark out, or you can use a compass to mark out how exactly the length. So based on this, I need to find out 4,000, and 1 cm is 800, so that's 5 cm. Okay, so I don't need so long. It's okay. So I'm going to do that 5 cm because it's not such a big diagram. So it's somewhere here, to marking. So this is about 5 cm. You want to be as accurate as you can so you get an accurate answer. So I'm going to do an arrow. This is my 4,000 newtons. This is at 30 degrees. So now it's my time to draw the other one. Okay, this line is a bit too long, so I'm going to erase this part. So this part is not really needed. Okay, the next part here is to draw the bottom one. I will mark out the angle first. Okay, and then I will extend the line. Again, it's going to be 5 cm because it is also 4,000. So I'm just going to draw the line. Not too long since I know it's 5 cm. And I will mark out 5 cm. So that way it's somewhere here. Okay, so the rest of it I don't really need it. Okay, so now I have this. The next part is the crucial part. So this is where I'm going to show you the parallelogram method. So up to now, I have not done anything other than just replicating what the question has given. There are times the question already gives you a base to work with, and then you just need to add on. But in this case, you have to draw everything. So that's how I start off. Now the next part, I need to use the parallelogram method. So how I do this, basically I need to make sure that this length here is being marked here, and this length here is being marked here. Okay, so how do I do that? So I'm going to show you step by step. First, I need to extend my compass such that it is 5 cm. Okay, so once that is done, I'm going to do this one first. So this is at here. So parallelogram means to extend this onto the here, and I'm going to do a marking here. A big one, so I don't redo it in case I do it wrong. And then I just check again, it's still 5 cm because it can be a bit yeah, it's not really 5 cm. Okay, so maybe I'm going to erase this. So the thing is, some of this compass is a bit loose, and therefore you will have some problems. Okay, so let's just try that again. Okay, 5 cm. Line here. And now this one, because this question happens to be the same length, I don't need to change the length because it is from here to here. But if let's say this length is slightly different, you have to adjust the length again. Okay, so this is here. Mark it out. Oh no, this is really loose. I apologize for that. Let's try that again. There we go. Gonna erase the extra parts. Okay, so now I have done it. The last part of it is simply to join the line. Okay, this is the solid line I will draw because this is the resultant force. I will do it with a double arrow. The other two to show construction is this dotted line. This to represent the parallelogram that I've done. And here. Okay. So there we have. Now the final step for this is to actually measure the length here as well as measure the angle. So that will tell us how long is our resultant force and in what direction. So in this case, this is 9.2 cm. I'm going to bracket it because you're supposed to put in the force instead here. So 1 cm gives me 800 newtons. 9.2 cm would give me, so 800 times 9.2, I get 7360. So then I'll put 7360 newtons here. Okay, so this is almost at the end. Most of the time the question doesn't require you to measure the angle, but in this case, because there's a particular angle, we're going to measure it. So we're going to take the protractor, put it here, and in this case this looks like it's about 90 degrees. So I'm going to make sure that 90 degrees. So this is 760, 9 degrees from the horizontal. Okay, so this is the final answer. If you have any question, you just let me know. Okay, so this is the parallelogram method. I'm not going to show the triangle method. The triangle method only works in certain situations, while in this case, it is much easier to do the parallelogram method. Okay.